Good morning, students. Welcome to PowerPoint YouTube class. I am your host, Oyerinde Tunde Daniel, and in this PowerPoint YouTube class, we'll be discussing a question from light and optics. We'll be discussing a selected question from the topic that we've treated, which is light and optics. Although we've already, the parallel beam of light is said to be obtained from the headlamp of a car. At which of the following position should the source of light be placed from the pole of its spherical mirror? It should be placed at the focal point. Number 2, which of the following pairs of light rays show the widest separation in the spectrum of white light? The answer is C, that is red and indigo. And I've added another diagram to explain this better. Number 3, an image which can be formed on the screen is said to be real. Any image that can be formed on the screen is said to be a real image. And this diagram shows the differences between real image and virtual image. A real image is an image which is formed when the light ray meets at a particular point after reflection from the mirror, while a virtual image refers to the image which forms when light rays appear to meet at different points after reflection from the mirror. Question 4 says, which part of the camera corresponds to the iris of the eye? The part of the camera that corresponds to the iris of the eye is the diaphragm. Number 5 says, at which of the following distances from the lens should a slide be placed in a slide projector? If f is the focal length of the projection lens, it should be placed at distance equals to 2f, that is 2 times the focal length, which is d. 6 say, which of the following is used for controlling the amount of light entering the eye? The iris is the part of the eye that controls the amount of light entering the eye. Number 7, which of the following statement is not correct for light ray passing through a rectangular glass prism when surrounded by air? The answer is it is deviated at the point of emergence. Now let's discuss long-sightedness. Long-sightedness occurs when the eyeball is slightly too short so that the focal point is behind the retina at the back of the eye. And this can be correct. This diagram shows what happens to a long-sighted person or a long-sighted eye. And this is how it can be corrected. Long-sightedness can be corrected by use of a convex mirror. So to correct long-sightedness, we use a convex mirror. Short-sightedness or myopia is a very common eye condition that causes distant objects to apply blur. And this diagram shows the causes of short-sightedness. And this one shows how it can be corrected. It can be corrected by use of a concave lens. Remember, long-sightedness is corrected by use of a convex lens, while short-sightedness is corrected by use of a concave lens. Let me repeat this question again. An image which can not be formed on the screen is said to be virtual. The ability of the eye to focus near object is known as long sight, and the image of any object formed by a divergent lens is always real. The image of any real object formed by a divergent lens is always real. That's question 10, which is D. Question 8, the answer is C. Question 9, the answer is A, and question 10, the answer is D. So let's look at question 11, which says when a ray of light is incident normally on air to glass interface, the angle of refraction is always 0 degrees. Number 12 says when white light is incident on a glass, the spectrum produced on a screen placed beyond the prism is due to a phenomenon called diffraction. Please look at number 12 again. It says when white light is incident on a glass, the spectrum produced on a screen placed beyond the prism is due to the phenomenon of diffraction. Question 13 says, which of the following distances is usually adjustable in the camera? The distance between the lens and the film is a distance which is usually adjustable in a camera. The diaphragm and the shooter, shooter and film, diaphragm and film is incorrect. So the answer is what? The lens and the film is usually adjustable in a camera. In which of the following piece of apparatus is the radius of curvature equals to twice the focal length? It is all among the option here, C is the correct answer. In a converging mirror, the radius of curvature is equals to twice the focal length. A concave mirror can be used to produce a parallel beam of light if a lighted bulb is placed where? That is, if the lighted bulb is placed at its focus. That's option B. Question 16 says, a lens that is thinner at the middle and thicker at the edge is divergent lens. So a divergent lens is thinner at the middle and thicker at the edges. Question 17 says, which of the following is not true of the similarity between camera and human eye? A, B, and C are true, but the one which is not true is D, which says that the distance between the lens and the screen is fixed in both. Option D is absolutely not true, but option A, B, and C are true, but option D is the correct answer, which is not true. What is the image distance of an object placed at a distance of 2f from the converging lens of the focal length f? The answer is D, which is 2f. Which of the following statement is not correct about long sight? A, B, C are correct, but D is not correct. The defect is corrected by use of a divergent lens. I've explained that before. It's not corrected by divergent lens. Number 20, which of the following condition is necessary for the occurrence of total internal reflection of light? For total internal reflection of light to occur, the angle of incidence must be greater than the critical angle. Again, for the occurrence of the condition for occurrence of total internal reflection of light is that the angle of incidence must be greater than the critical angle. That's option C, meaning option A, B, and D are not correct, but option C is the correct answer. The angle of deviation of light of various color passing through a glass prism decreases in order of blue, orange, and red. The order in which the angle of deviation of a light of various color passing through a glass prism, it decreases in the order of blue, orange, and red. Question 22. A magnifying a virtual image of a near object is produced by a simple microscope. So a simple microscope produces a magnified and visual image of a near object. That's what a simple microscope does. 23 says the image of an optical pin placed at the principal focus of a concave mirror will be formed at infinity. Again, when an object is placed at the principal focus of a concave mirror, the image will be formed at infinity. Which of the following statements about human eye and camera is correct? The focal length of both the eye lens and the camera can be varied. It is not A, it is not B, it is not C, but the answer is D, which says that the focal length of both the eye lens and the camera lens can be varied. 25. In the normal use of a simple microscope, a person sees an erect, visual, and magnified image. That is, in the use of microscope, what kind of image will a person see? The image will be erect, the image will be real, and the image will be magnified. A piece of cloth appears green in sunlight, which held in red light will appear what color? That's question 26. It will appear black. It will not appear green, it will not appear blue, it will not appear red, but it will appear black. 27 says dispersion of white light by a glass prism occur. That is, what is responsible for dispersion of light by a glass prism? It occurs because the speed of each color of light in the glass is proportional to angle of refraction in the prism. Again, it occurs because the speed of each color of light in glass is proportional to the angle of refraction in the prism. 28. Which of the following statements about sound is correct? We have four statements here. The one that is correct is C. That is, the wavelength of sound changes when it travels from air to water. Again, the correct answer is that the wavelength of sound changes when it travels from air to water. 29. Dispersion of white light is the ability of white light to separate into its component color. Again, the dispersion of white light is the ability of white. The dispersion of white light is the ability of white light to separate into its component color. 30 said the use of lenses is not applicable in. The use of lenses is applicable in projector, is applicable in human eye and telescope, but it is not applicable in periscope. The range of accommodation of normal human eyes is in the range of 0.25 meter to infinity. So the question here says the range of accommodation of normal human eyes is 0.25 meter to infinity. That's question 31. 32. The plane mirror in a kaleidoscope are usually placed at what angle? A plane mirror in a kaleidoscope are usually placed at angle 60 degrees. For correcting a long sight defect in human, we require what? So for correction of long sight defect, it involves the use of a converging lens. 24. Dispersion of white light by a glass prism occur because of not option A, B, or C, but because of option D, which is the speed of each color of light in the glass is proportional to angle of refraction in the prism. Again, the speed of each color of light in the glass is proportional to angle of refraction in the prism. 35 says total internal reflection will not occur when light travels from water to air, glass to air, water to glass. It will not occur when light travels from glass into water. Which of the following arrangement sequence shown can be used to obtain a pure spectrum of white light? A pure spectrum of white light is only obtainable using this arrangement: the source, the slit, the converging lens, the prism, converging lens, as well as the screen. In our Zoom class, I will explain this better, but for emphasis sake, in order to obtain a pure spectrum of white light, the arrangement is in this order: source, slit, converging lens, prism, converging lens, and screen. When a ray of light passes from water to glass, what happens? The question says when a ray of light passes from water to glass, it is bent away from the normal. Again, when a ray of light passes from water to glass, it is always bent away from the normal. 26. Which of the following characteristics of wave is used in measuring the depth of the sea? We have diffraction, reflection, refraction, and interference. The answer is reflection. Again, which of the following characteristics of wave is used in the measurement of the depth of sea? The characteristics used in measuring the depth of the sea is reflection. A spectrum of sunlight is said to be impure. This question means when is the spectrum of sunlight said to be impure? It is said to be impure when the colors in it overlap differently. So when the color in it overlap differently, it forms an impure spectrum. Which of the following statements is correct about a long-sighted boy who does not put on glasses? A, B, C are incorrect, but D is correct. Parallel rays of light are focused behind the retina. So when rays of light are focused behind the retina, it is what is responsible for long-sightedness. So long-sightedness occurs because parallel rays of light are focused behind the retina. A submarine is observed to rise from a real depth of 80 meter to 60 meter in water. Calculate the change in apparent depth. This is a calculation. Remember, apparent depth is equal to refractive index. Apparent depth is equal to refractive index. Apparent depth is equal to Please, apparent depth is equal to refractive index all over real depth. I will explain this better in our Zoom class, and the answer is 15 meter. This question says a pool of water appears to be 1.0 meter deep when viewed vertically from above. If the refractive index is 1.33, what is the actual depth of the pool? This one is refractive index is equal to real depth all over apparent depth. So real depth is equal to refractive index times apparent depth. So when you multiply refractive index times the apparent depth, it will give you 1.33 meter. So the answer is C. Remember, I said this question, I will explain it better in the Zoom class. That is question 29. I have a reason for that. Question 30 says, if the refractive index of the medium in air is 2.0, what is the critical angle for this medium? Also, this question, I will explain it more in the Zoom class, but using this formula, sin C is equal to 1 over n. So where n is our refractive index, which is 2. So 1 divided by 2 will give us 0.5, and the sine inverse of 0.5 is 30 degrees. Let's quickly explain total internal reflection as well as critical angle. The angle of incidence that causes angle of refraction to equal to 90 degrees is called the critical angle. While total internal reflection is when the angle of refraction is 90 degrees or greater. The total light is reflected back to the original material and no light enter the new material. This is when we say total internal reflection has taken place. This is a formula for calculating a critical. This is a formula that this is a Snell's law formula that is applicable to critical angle. As I said, I will explain more of this in the Zoom class. This question says an object is placed 10 meters from a pinhole camera of length. An object is placed 10 meters from a pinhole camera of length 25 centimeters. Calculate the linear magnification. First, we have to convert 25 meter to centimeter, and to do this, we'll divide it by 10. If you do that, it will give you 0.25. So linear magnification is equal to V over U. So if we do 0.25 divided by 10, it will give us 0.025 centimeter as our linear magnification. The focal length of a concave mirror is 2.0 centimeter. If an object is placed 8.0 centimeter from it, the image is at. Now applying using 1 over V equals to 1 over F minus 1 over U. If we do that, substitute it in our value, it will give us 1 over V is equals to 3 over 8. But V, if you make V the subject of the formula, it becomes 8 over 3. And when we do that, it will give us 2.7. I will explain this furthermore also in the Zoom class. An image in a convex lens is upright and magnified 3 times. If the focal length of the lens is 15 centimeter, what is the object's distance? The object distance is 10 centimeter. Also, if we use 1 over U minus 1 over V equals to 1 over F, if we do all the manipulation, our U will give us 10 centimeter. All these questions that appear complex, I need you to study it. If you have any question, when we meet in our Zoom class, ask me that question, and if you don't have any question, I will explain it further in the Zoom class. This question says a certain 5-sided person cannot see objects that are closer to the eye than 50 centimeters clearly. Determine the power of the converging lens which can enable him see at 25 meters. For us, the power of a lens is 1 over focal length. So we need to find our focal length and take the reciprocal. So our focal length, by using 1 over U plus 1 over V equals to 1 over F, our focal length is 17 centimeters. So 1 over 17 centimeters will give us 0.06 diopole. 36 said the refractive index of a medium relatively to air is 1.8. Calculate the critical angle for the medium to the nearest degree. As I said earlier, our refractive index is the ratio of sine of angle of incidence to sine of angle of refraction from air to glass. And we just use sine c equals to 1 over 8. When we take the sine inverse of 1 over 8, it will give us 0.5. Okay, the sine inverse of 1 over 8 will give us 34 degrees. Also, I will ensure this is well explained again in our Zoom class. A simple magnifying glass is used to view an object. At what distance from the lens must the object be placed so that an image 5 times the size of the object produce 20 centimeters from the lens? The answer is 4 centimeters. Remember, magnification is equal to image height over object height. When you make U your subject, it will give you 4 centimeters. The real image of an object formed by a converging lens of focal length 15 centimeters is 3 times the size of the object. Calculate the object distance. The object distance is 20 centimeters. When we apply 1 over U plus 1 over V equals to 1 over F, where our F is 15 centimeters, our V is equals to 3U. Doing mathematical multiplication, our U will be 20 centimeters. A magnified and visual image of a near object is produced by a simple microscope. So a simple microscope is used to produce a magnified and visual image of a near object. And this diagram shows what a simple microscope looks like. I would like you to study it properly. At least you should be able to identify what a simple microscope looks like. A simple microscope is a magnifying glass that has a double convex lens with a short focal length. So the focal length of a simple microscope is usually very short. This question says the diagram below, what does it represent? It represents a simple, or it is an astronomical telescope. So what this question wants you to know is to be able to identify what an astronomical telescope looks like. You can meet it in any exam where they will ask you that this diagram, what does it look like? So please study it and know what an astronomical telescope looks like. This one says the diagram represents what? This diagram is not a prism binocular, it is not astronomical telescope, but it is what? A compound microscope. A compound microscope. So the term compound in compound microscopes, refer to the microscope having more than one lens. So please, you should be able to identify a simple microscope. This is a simple microscope, and this is what? A compound microscope. But this is what a microscope looks like in real life. But this is a diagram of a compound microscope. The diagram represents what? This diagram represents a Galilean telescope. This is a diagram that shows a Galilean telescope. So let's look at a Galilean telescope. Is an instrument for viewing distant objects named after great Italian scientist Galileo Galilei, who first constructed one in 1609. This is what a Galilean telescope looks like. Now the diagram represents what? This is what an astronomical telescope looks like. This is an astronomical telescope, and this is what? A Galilean telescope. Please, I want you to study it properly. Identify a simple microscope, which is this is a simple microscope. This is a complex, or this is astronomical telescope. This is a compound microscope. This is a Galilean telescope, and this is what an astronomical telescope looks like. So the question for 3 says the diagram represents what? It represents an astronomical telescope. An object is moved close to the focus of a converging lens from infinity. Its image is moved away from the lens. So D is the correct answer. Please study this question properly. I think I will need to explain this better in the Zoom class. The human lenses is not applicable in periscope. I've said this before. The use of lenses is not applicable in periscope. The use of lenses is applicable in projector, it's applicable in human eyes, it's applicable in telescope, but it is not applicable in periscope. This is what a periscope looks like. Periscope is usually constructed using mirror, which is always inclined at an angle 45 degrees. Periscope is an instrument for observation over, around, or through an object, obstacle, or condition that prevent direct line of sight of observation from observer current position. Discussion. Our lesson is coming to an end. When a ray of light passes from a less dense material, e.g. air, to a denser material, e.g. glass, it bends away from the surface between the two materials. Please study this very well. At this point, I want to say thank you and God bless you.